Hello guys, welcome back to Civil Engineering Tutor. This is day 2 of our test series discussion. This is a short introduction about my qualification. If you are interested or curious to know about my qualification, you can pause the video and watch this. Now this is a short instruction which I already discussed in day 1, but I am again repeating that be ready with a pen and paper and try to find the correct answer by your own first. I will give you 10 to 15 second time. Okay, after that I will show you the correct answer and explain the concepts. So all the best. In day 1 we have discussed 10 questions. So from this video we will start from question number 11. In situ vein shear test is used to measure shear strength of sandy soil, steep clays, very soft and sensitive clays, gravel. So today I have included very easy type of questions. So I think most of you will get more than 5 out of 10. Okay, and try to comment down your score out of 10 so that I can understand that what is your level of preparation. So I think most of you have got this correct answer for this question. The correct answer is very soft and sensitive clays. This is a typical vein shear test apparatus. You can see these are known as blades or vanes. Generally 4 blades or vanes are there in a vein shear test apparatus. So this correct answer for this question is very soft and sensitive clays. Next question, the ratio of the depth of the parabolic and rectangular portion block at the limiting state of collapse of a singly reinforced section is. So we need to find the depth ratio of the parabolic and rectangular portion. So most of you remember the diagram for singly reinforced section. What is the stress distribution and strain distribution? In this picture you can see this is the typical stress and strain distribution diagram. Here this portion is parabolic and this above portion is rectangular in shape. Now we need to find what is the depth ratio of this portion and this portion. Okay, so at first we need to find the depth ratio for parabolic and then depth ratio of rectangular. So this is the strain values for 2 different depth limits. So from using similar triangle properties, we can say that BC by AC, that means this depth by total depth is equal to this value by this total strain value. So here the ratio for BC by AC we got 4 by 7. And similarly, if we got this value or this ratio, then we can find the above one because this total depth is XU. You can see here this total depth is XU. And we already found that BC is equal to 4 by 7 XU. Okay, so we can find the rest of the portion, that means the rectangular portion depth AB. AB is equal to XU total depth minus 4 by 7 XU. That means total depth subtracting that parabolic portion. So here this above depth will be 3 by 7 XU. So if we divide BC by AB, we will get 4:3. So the correct answer will be B. This is very easy questions. Those who have studied singly reinforced section design, you must have got this answer very quickly. So next question, the spacing of stirrups in a beam is the same everywhere. Is it so? I don't think so. Depends on the size of the beam. I don't think so. Increases near the support and decreases near the support. Now we have to choose the correct answer, which one is correct. So here, as we know that stirrups are provided to prevent shear. So now we need to understand that what is the shear force distribution in any kind of simply supported, let's suppose a simply supported beam, and there is some UDL is acting on that beam. Okay, you will get this kind of shear force variation, that at the supports this has maximum value, but at the center it is minimum value. So that means that we need to provide closer stirrups at the supports. Okay, and the spacing of stirrups may be greater in center. So the correct answer for this will be decreases near the support, because we need to provide stirrups closely to prevent the maximum shear force developed at the supports. So here in this beam we can see this is a typical reinforcement in a site. Okay, so this is in this beam you can see that these are the portion near the supports. Okay, these portions are near the supports, but this is the mid section. So you can see that spacing here is more as compared to here. Now next question, lifting the corners of slab is prevented by providing dash reinforcement. Which kind of reinforcement is provided to prevent the lifting? Torsion, shear, transverse or longitudinal? So who have designed 2A slab section, you must have got the correct answer, and the correct answer is torsion. Here you can see that for a 2A slab, these are the corner reinforcement. Okay, and these are provided to prevent the lifting of corners. Isohyetal method is used for determination of evapotranspiration, seepage loss, precipitation or intensity of flood, and the correct answer is obviously precipitation. So these are the method used for measuring or determination of precipitation, that are arithmetical mean method, Thiensen polygon method, and Isohyetal method. And among these three methods, Isohyetal method is the best method. Now you should remember this also, that what is isoheights? Isoheights are line joining points of equal rainfall. Next, the resistance offered to slipping of steel bars from concrete is due to three options is given: pure adhesion, frictional resistance, mechanical resistance. Now we have to find out which sequence is correct. Only one is correct, 2 and 3 is correct, 1 and 3 is correct, and all these are correct. So we need to find it. So here correct answer will be D, all the three. So just remember this concept, that resistance offered in RCC, that means between steel and concrete, is due to the following points or following properties. Number one is pure adhesion. Adhesion means what? Attraction between two different materials. So in RCC we have steel and we have concrete. So during hydration, concrete produces gum-like materials, okay, and that materials stick to the surface of steel. So this is a pure adhesion case. So due to this, slipping is prevented. Number two is frictional resistance. What is frictional resistance? We know that the surface of the steel has some degree of roughness. So due to that surface roughness, the reinforcement and the concrete is bonded together. Third one is mechanical resistance. This is due to deformed bars. And final is gripping action. That is due to the drying of concrete. So just remember these 4 points. It may be asked in any way. Next, the diameter of transverse reinforcement of columns should be equal to 1/4 of the diameter of the main steel rods, but not less than. So we know that this is the codal provision, that diameter of lateral or transverse reinforcement that we use, that should be 1/4 of diameter of the main steel bar, but there is a minimum value, and that minimum value is what? 4 mm, 5 mm, 6 mm, or 7 mm. So you just need to remember this codal provisions, and the correct answer for this will be C, 6 mm. Next, which of the following instrument is used to measure small color intensities precisely? You have nephelometer, you have tintometer, Bailey's turbidimeter, Nessler tube. So here we know Bailey's turbidimeter is used for turbidity measurement. Nephelometer is also used for turbidity measurement. Now we have tintometer and Nessler's tubes. So the correct answer for this case will be B, tintometer. Here is the chart. Just remember this, that for turbidity, what are the different tests? We can see that Bailey's turbidity is there, nephelometer is there, and for color, we can see tintometer is there. Taste and odor is measured using osmoscope. Okay. Next, which coagulant is widely used for sewage treatment? Lime, alum, ferric chloride, ferric sulfate. And the correct answer for this case will be ferric chloride. Just remember this, that alum is mainly used for water treatment, but ferric chloride is used for sewage treatment. So just remember this thing. So before moving towards the final question, I have a request for you. Please comment down your score out of 10 so that I can understand what is your level of preparation, and I will include questions accordingly so that you will do not feel demotivated. Number one thing. And number two thing, if this video is anyway helpful, please like this video and subscribe to this channel. Your like and subscribe will give me motivation to make more videos like this, and I can understand that you are really enjoying the videos. If you do not enjoy, there is no purpose to make the videos. Okay. So final question, contour interval within the limits of a map may be kept constant, must be kept constant, may not be kept constant, may be vary according to the configuration. So contour interval, from the term itself you can understand that contour is the line of equal depth or height whatsoever, and contour intervals are lines of constant intervals, you can say. So here contour lines, the definition of contour lines is given, that these are lines joining the points of equal elevation, and contour intervals itself are contour interval, it is the constant vertical distance between two consecutive contours. Okay, that is contour interval. So from the definition we can see that this should be constant. Like here in this case we can see this is a contour diagram for overhanging cliff. We generally know that contour lines do not intersect, but this is only exception, that here contour lines intersect each other, and we can see that difference is 5 in this contour diagram, 100, then 105, and then 110. So this is contour. So in this case contour interval is 5, and that is constant. So that's it for today. Hope you got more than 5. So please comment down your marks and like this video and subscribe to the channel. Thank you very much.